A linear equation in two unknowns has the form ax plus by equals c, where x and y are unknown numbers and a, b and c are given numbers. Usually letters at the end of the alphabet denote unknown values, so letters like x, y or z. Letters at the beginning of the alphabet are used to denote given values, values that we know, letters like a, b and c. So we will have a, b and c. X and y are free to vary, but the pair of numbers x and y must satisfy this equation. In other words, ax plus by must work out to the right hand side, which is c. It is called a linear equation because its graph is a straight line. If we have two linear equations, then there may be a pair of numbers x, y which satisfy both equations simultaneously. As an example, the solution to the pair of simultaneous equations 2x plus 3y equals 4 and minus 3x plus 5y equals 13 is x equals minus 1 and y equals 2. As a check, I will show you that x equals minus 1 and y equals 2 satisfies this first equation, which I've written down here. So we replace x with minus 1 and we replace y with plus 2. And this should all work out to 4. We get 2 times minus 1, which is minus 2, plus 3 times 2, which is 6. Minus 2 plus 6 is indeed plus 4. So it does check out. So that tells us that the pair of numbers minus 1, 2 satisfies 2x plus 3y equals 4. Now let's check the second equation. Minus 3x plus 5y equals 13. So we plug minus 1 in for x. So we get minus 3 times minus 1. And we plug 2 in for y. So we just write out the left hand side, replacing x with minus 1 and y with 2. Calculating this, we get minus 3 by minus 1 is plus 3, plus 5 2s are 10. This works out to 13. This does indeed work out to the right hand side of the equation. So this shows that the pair of numbers x equals minus 1 and y equals 2 satisfies both equations simultaneously. Now we can write this pair of numbers as a point in coordinate geometry. The first value is the x value and the second value is the y value. It's the point where the graphs of the two equations cross. So the graphs of both equations are straight lines and they cross at the point with coordinates minus 1, 2. The next thing I want to do is show you how to find the pair of numbers that satisfy both linear simultaneous equations simultaneously. The first method is what I could call combining and cancelling. That is, we combine the two equations together in such a way that we cancel either the x terms or the y terms. To do that, we may have to take a multiple of one equation and add it onto a multiple of the second equation. For example, to cancel the x terms, we would have to turn this term into minus 6x and turn this one here into plus 6x, so that when we combine the equations, in other words add them, the x terms will cancel out. Minus 6x plus 6x gives 0. There are two things we can do with a pair of equations. One thing is that we can multiply an equation by any number we like and it won't change the equation. I'll just show you a very simple example with numbers to illustrate that fact. Suppose we have a very simple equation without x's or y's. I'll just take the two numbers minus 3 plus 5. We know that that's equal to 2. Well, if we multiply all of this equation by 2, what do we get? We get minus 6 plus 10 equals 4. And that is of course true. Let's suppose we have another equation given by the following. Plus 6 plus 1 equals 7. And suppose we decide to combine these two equations here. So I want to combine these two equations. What you can do is you can add the left hand sides together and we will get something that's equal to the sum of the right hand sides. And I can add them like this. Minus 6 plus 6 gives 0, or they cancel out. 10 plus 1 is 11. 4 plus 7 is 11. So you can see that that checks out. So what you can do is you can add the left hand side of an equation to one side of another equation and add the right hand side of that first equation to the other side of another equation, and we don't change anything. We get an equation that is true. We get something that's true. So These are the two operations we will be using. We'll be multiplying an equation by a number, like this equation was multiplied by 2. And the second thing we'll do is combine two equations by adding them or subtracting. So what I will do here is take this equation and multiply it by 2. The reason why is because I want to turn this term into minus 6x. If I multiply the second equation by 3, I will turn this term into plus 6x. And then when I add the equations, the x terms will cancel out. So multiplying all this by 2, we get minus 6x plus 10y equals 2 times 13 is 26. Here we get 3 times 2 is plus 6x, 3 3s are 9, 3 4s are 12. That's allowed, of course. We've multiplied an equation all the way across by a number, so we haven't really changed it. The form has changed, but the equations are the same. The next thing we can do is add these two equations together. So you can see now why we chose the numbers 2 and 3, because we want to get minus 6x here and plus 6x here. Essentially, we multiply minus 3 by the 2, and we multiply the 2 by the minus 3. Now, in the next step, what we're doing is we're taking this equation here and adding the top equation to it. So we're going to add all of this onto the left-hand side of our equation, and we'll multiply 26 onto the right-hand side of the equation. You see, we're adding the same thing. See, minus 6x plus 10y equals 26. We're adding the same thing to both sides of this. If you add the same thing to both sides of an equation, you don't change it. Well, you get an equation you get something that is indeed an equation. You'll see that in a minute. Minus 6x plus 6x gives 0, plus 10y plus 9y gives 19y. You will find that 19y equals 26 plus 12, which is 38. And now you see we have an equation with just one unknown. So we can find what y is. So y is 38 divided by 19, which is 2. So that's the y value of the point of intersection of our two lines. Now, how do we find the x value? Well, we could follow this procedure again and try to cancel our y terms. We could actually multiply this equation up here by minus 3, so this term becomes minus 15y. And multiply this second equation by plus 5, so this term becomes plus 15y. And when we add the two equations, the y terms will cancel, and we can solve for x. We could do that, or we could do a somewhat easier way, which is to plug this value that we got for y into one of these equations and solve for x. So I'll take the second equation here. It doesn't matter, you could use either equation, of course. So if I take the second equation, plug 2 in for y, so we get 2x plus 3 times 2 equals 4. Solve this equation for x. We get 2x equals 4 minus 6 is minus 2, which means that x equals minus 2 divided by plus 2 is minus 1. So that's the x value of the point of intersection of the two lines. The second method that I would like to show you is substitution. Now, the substitution method has to be used when we're solving between a linear equation and a nonlinear equation, which I will cover in the next video. So you don't have to apply it here. The cancelling method works fine, but I'll just run through this method anyway. Now, to apply this method, what we do is we make x or y the subject of one equation. So I will pick this equation here, 2x plus 3y equals 4, and I will make x the subject of it. So you can pick either equation, and you can make either x or y the subject. It doesn't matter. So what I will do is I'll choose to make x the subject here. So we get 2x equals 4 minus 3y, and that means that x equals 4 minus 3y all divided by 2. So I've made x the subject of 2x plus 3y equals 4. I've got x in terms of y. The next step is to substitute this equation here into the second equation. So the second equation is this one here. So I write this equation out, but I replace x with 4 minus 3y over 2. So I can write 4 minus 3y over 2 in brackets. And I just copy out the rest of this. Now, this equation has just one unknown. It has y in it, so I solve this equation to find out what y is. So multiplying in here, I multiply the minus 3 by what's on top, of course. I have minus 3 by 4, that's 12. It's minus 12 actually. And I'll have minus 12 divided by plus 2, which is minus 6. Then I have minus 3 by minus 3y, that's plus 9y. Plus 9y over 2 is 9y over 2, or 9 over 2y. Then I copy out the rest of this, and I solve this for y. So I combine the y terms together. 9 over 2 is 4.5 or 4.5. 4.5 plus 5 is 9.5. So I get 9.5y equals 13 on the right hand side plus 6, which is 19. So y equals 19 divided by 9.5. That's actually 2. Having found y, I then go and plug it into this here. So I get x equals 4 minus 3 times 2 divided by 2. So this will give me 4 minus 6 is minus 2 divided by plus 2 is minus 1, as before.